Thank you very much. I suppose, first of all, for those who are attending tonight in person and also for those who are tuned in online, I believe we have quite a good following online this evening, so that's great to see. I suppose a special thanks to John, Michal and Francis as well for inviting us to come here to present here tonight and for facilitating the event. And I suppose it's a great opportunity to speak to you all tonight. As Michal's introduction said, I'm Director of Operations with Glanua. I'm an alumni of what was in my day IT Sligo, now ATU Sligo. And I graduated in 2009 from IT Sligo. So back then we were in the height of a recession. I was very fortunate to get a job with Glanua, as we were known back then. And that allowed me to progress a career in the water sector. And as Glanua grew and became Glanua, it's allowed me to progress with the company as well and evolve my career. I suppose essentially you might wonder what an operations director does. I look after the design and build phase of all of our projects that are delivered in the water and wastewater sector. The agenda we're going to cover tonight probably take around 35 minutes, as Michal said, and then we'll have plenty of time at the end for a Q&A session. We're going to cover the importance of water, I suppose how that plays and impacts on the municipal, the industrial and the pharmaceutical sectors. So hopefully there's something for everyone. And I see a few from the industry here tonight as well, which is great to see as well. Glanua's role within the water and wastewater industry, challenges that we're facing in both Ireland and the UK, and a lot of common challenges within that. There are plenty of opportunities, and I suppose with every challenge there comes an opportunity. Plenty of opportunities in the industry. I'll probably pick 3 this evening just to have a discussion on, and welcome Q&A on that at the end as well. Early contractor involvement, or ECI for short, sustainability, and we'll probably look at some of the initiatives that are happening right now, but also what the future of sustainability in the water sector looks like as well. We'll have a discussion then on modular design, design for manufacture and offsite assembly, or DFMA for short, offsite fabrication, and then, as I said, we'll have plenty of time at the end for a Q&A session. I suppose water and public sector, water and wastewater treatment, and indeed industrial, it's highly important, as we know. The United Nations set 17 goals in 2016 for global goals for people and planet, covering social, environmental and economic targets. And it was interesting, you might have heard in the news today that there's been a relaunch as such of these Sustainable Development Goals at the UN General Assembly. And I suppose attention had been diverted away. You know, we had COVID-19 since 2016, we had a war in Ukraine. So I suppose they're trying to relaunch these sustainability goals and focus on those again. But number 6 there, as you can see, it covers the ensuring the availability and sustainable management of water and sanitisation for all. And, you know, it's very important that we build today without impacting this generation and future generations when we're doing that as well. And, you know, we need to ensure, it's a common tagline, but it's very prevalent. We need to ensure that we secure our water for our future. I suppose it is a public health concern. You know, water is essentially a food product. It's consumed by the general public. It's used in industry. And it's key to sustaining industry and sustaining life within our communities as well. And we sometimes take water for granted, you know. There are many countries out there that still have to walk daily to get water, and even in developing countries, it still spreads diseases such as cholera. So we're very lucky to have an advanced, safe and secure drinking water supply. I suppose treatment of water and the eventual treatment of wastewater and discharge back into the environment, it's a continuous cycle. And it's said that water that we drink today has been drank 10 times over at this stage, indeed by dinosaurs way back when. 200 odd million years ago, the same water molecules have been drank for millions and millions of years. So I suppose, I know what everyone maybe is thinking is that, you know, we've no shortage of water in Ireland. Sure, doesn't it rain every day? And we're surrounded by lakes, we're surrounded by rivers. And, you know, we are very fortunate to have sources of fresh water in Ireland. You know, there's still many countries out there that rely on desalination processes to generate potable, clean drinking water. We're very fortunate to have sources of fresh water readily available to us. Excuse me, but there's a lot of treatment, I suppose, that goes on behind the scenes to make that water fit for human consumption, safe and secure to drink. That largely goes on behind the scenes. I suppose another common misconception is that we have the most beautiful rivers and beaches in the world, and that's correct. We do have very beautiful rivers and beaches, but I suppose the reality is that there's still locations around Ireland where we discharge raw sewage into our watercourses. And until recently, there was over 40 discharges of raw sewage around the country. I know I'm painting a very bleak picture there, and thankfully, since the formation of Uisce Éireann in 2013, over 60% of these untreated agglomerations have been alleviated, and the remainder will be alleviated by the end of 2025. So the impact, I suppose, of water and wastewater on the municipal, industrial and pharmaceutical sectors. I suppose Uisce Éireann, as I said before, was formed in 2013. They would produce and supply about 82% of drinking water to the population of Ireland. The balance then is made up by privately owned cooperative group water schemes and private household supplies, be it through borehole sources or spring sources. Similarly, I suppose on the wastewater side, about 2/3 of wastewater services are provided by Uisce Éireann. And again, the balance of that is through private household systems or private community-owned systems and housing estates, for example. The industrial pharmaceutical side, I suppose water is key to sustaining industry and pharma. You know, without water and wastewater services, these industries wouldn't be able to operate. It's as simple as that. Some industries also require ultra pure water, depending on what their process is or their manufacturing facility requires. I suppose a case study, it's information readily available online, but Intel uses approximately 10 million cubic meters of water each year, and it's supplied by the leak slip water treatment plant. And thankfully, you know, a large percentage of that water is treated and returned back into the environment safely. I suppose industrial wastewater then is a byproduct of some industries as well. And you know, some of these industries, for example, we operate ourselves a lot in the dairy and the meat industry, would be generating high BOD waste. Blood and milk are two of the highest BOD contaminants. So we have to be very careful that we treat that wastewater adequately before returning it to the environment or discharging it into the public sewer system for further treatment. Water and wastewater services, I suppose, are key to the growth of our economy. It goes without saying. I suppose the attraction of these large multinational companies without the investment, I suppose, in our water infrastructure, you know, it's as simple as this: planning permission won't be granted for these large facilities because there's nothing to support them. As I said before, the water cycle is a continuous cycle from drinking water to wastewater and back into drinking water. It's been in operation for millions of years. I suppose it starts with abstraction at source. And as I said before, we're very fortunate in this country to have multiple sources of fresh water from lakes, rivers and streams, but also groundwater from boreholes and springs. Generally, I suppose it starts with abstraction, as I said, from the source, some level of screening. And then we enter our treatment process. And within this country, we have various different types of treatment processes, depending on the raw water characteristics. But commonly, we would use a process called CFC, or coagulation, flocculation, and clarification, followed by filtration. And then we'd have various different chemical dosing systems in terms of pH correction, chlorination for disinfection, and also UV disinfection as well. After treatment, then the water is stored in treated water reservoirs, either above ground tower reservoirs as indicated on the graphic, or ground level reservoirs or buried reservoirs, before distribution through networks into domestic households, but also into industry and pharmaceutical facilities. From those domestic and industrial facilities, then there's a collection of wastewater. And that wastewater is collected in sewer networks before being transported into wastewater treatment plants, where it undergoes preliminary screening, sometimes grit removal, fats, oils, greases removal, before entering a treatment process, which generally takes the form of primary treatment, some form of biological treatment, a final clarification, and then return into the environment. A little bit about Glanua then. I suppose we pride ourselves in award-winning innovations and engineering solutions. We're a team of around 350, actually I was looking last week, about 370 employees now within Ireland and the UK. We're on a growth trajectory at the moment. So we're on track this year for revenues up on 150 million for our group, which is great to see. And we're growing rapidly both in Ireland and in the UK as well. We have offices and manufacturing facilities all across UK and Ireland. In Ireland, our head office is based in Loughrea, County Galway. We also have a regional office and manufacturing facility in Navan in County Meath, and we have offices in London in the Thames Water region and in Sheffield in the Yorkshire Water region as well. We have over 65 international clients, I'll go through some of those in a moment. And we're all part of the Glanua group. And we've recently went through a bit of restructuring ourselves. Glanua was bought, or sorry, Glanagua as it was then, was bought by an Irish-owned company called BHSL last February. And we obtained a number of sister companies, including Hydro International. And we've rebranded our entire group now as Glanua Group under the one umbrella. Glanua Ireland and Glanua UK offer municipal water and wastewater solutions in both Ireland and the UK, respectively. Glanua Industrial offers water and wastewater solutions in the industrial and pharmaceutical space, and also water recycling and water reuse solutions as well to industry. And Glanua Civils underpins and supports all that with civil engineering solutions, primarily for the water industry. And that allows us to provide full turnkey solutions from the civil engineering and building side, all the way through to the mechanical, the electrical, process commissioning, operation and maintenance. As I said, we are what we call a DBO, design, build and operate contractor. So we have the capacity to do the full life cycle of the project. So from early optioneering and early contractor involvement design, through to detailed design, into the build phase, commissioning phase, process proving the plant, and then into operation and maintenance. And we operate around 61 water and wastewater treatment plants around the country. A little bit about our history. I suppose we're very proud of our history and the heritage and the depth, I suppose, of the experience that we have within our group. From the formation of our industrial business, Hydro International, back in 1995, the formation of Glanagua and MEIC, our municipal and our civils businesses back in 2008, through to the acquisition of Glanagua in last February in 2022, and now the eventual rebranding of the entire group of companies as Glanua. And this really gives us a platform for our growth. We're on, as I say, a huge growth trajectory at the moment. And this gives us a solid foundation to grow our companies. And we have some ambitious plans to expand both within our domestic Irish and UK market, but also globally as well. Some of our clients, I suppose in the municipal space, we have Uisce Éireann, who themselves have went through a bit of a rebrand this year as well. We also have numerous rural group water schemes in Ireland. There's far too many to mention, but we operate a lot of rural group water schemes around the country as well. We have in the UK then, we are active on Thames Water and Yorkshire Water frameworks in the London area and north of England, respectively. We also have completed projects in the past for Affinity Water, and we're going to showcase one of those later on in the presentation. And we're also active on the Northern Ireland Water framework as well, delivering projects in around the Belfast area. In the industrial and pharmaceutical space, I'm sure you recognise many of the household names there. We have worked for some of the major meat processing companies such as Keypack, ABP, Rostera Meats, also in the food and beverage industry, Dr. Pepper, for example, and different Manor Farms, different food manufacturing facilities, and also in the pharmaceutical space in terms of Merck Millipore, Wuxi Pharmaceuticals, AbbVie, MSD, and EMC Squared. I suppose I'm going to cover off a few of the challenges in the sector. I suppose, the fact of the matter is we have an aging infrastructure. And I suppose we have had a lack of investment down through the years. Thankfully, as I say, since the formation of Uisce Éireann, particularly on the municipal side, we've seen a lot of investment and focusing on delivering basic needs of water and wastewater treatment. And I suppose with the initiatives of, housing for all and increases in the private industry comes increased demands on our water and wastewater infrastructure. As we say, there'll be no cranes without drains. We need to have the infrastructure in place to support housing, but also to support industries. And oftentimes we see publications that planning permission has not been granted because there's no headroom capacity in the existing wastewater treatment plant in a certain community, for example. I suppose we're seeing increased climatic events as well, extreme weather events, in terms of wastewater. In terms of wastewater, I suppose this causes surcharging of combined sewers. And we have situations then where we get combined sewer overflows into the environment. On the opposite side of that, when we have drought conditions, it puts pressure on our sources of fresh water. So a lot of our plants, as I said, potable water plants will be supplied from lakes and shallow boreholes. And in drought conditions, the levels of these freshwater sources can deteriorate to such an extent that it places the public supply at jeopardy. And I suppose we do often hear about hosepipe bans, for example, and it's important we conserve our water because it is a valuable resource. I suppose a lot of you here and and dialed in online would be from the engineering community, and I'm sure you can relate that we have a shortage of technical engineering resources in this country, and also in trades, various different types of trades, and it is a huge problem that continues to put our national infrastructure and our national development plan at risk. And I suppose we, as in Glanua, are always looking and thinking outside the box how we can introduce more young talent into our engineering community. I was just telling the folks over by the dinner earlier that we've just launched our new graduate program, and we welcomed 21 graduates into a rotational graduate program this just 2 weeks ago as well. And I suppose overlapping and layered on top of all of this, we've got a movement towards net zero, and rightly so. And that's driven by our regulators through the CRU in Ireland and Ofwat in the UK. There's a huge ambition to head towards net zero movement, net zero targets. And all the while we've increasing standards. So the standards in terms of treated water supply into our households, into our local communities, is the headroom on that is ever increasing. And also in terms of wastewater quality, the discharges back into our environment. And generally that would require some form of an additional treatment process. And with any treatment process, generally speaking, it requires more energy. So we're having to reduce the carbon footprint of our activities, all the while introduce more treated water standards. So you've got this contesting amount of activity. In Uisce Éireann, I suppose some of the key targets in the revenue control period for investment plan: 50% energy improvement by 2030, 51% CO2 emissions reduction target by 2030, an achievement of net zero by 2040. The UK sector, even more ambitious plans again, net zero by 2030. And you can really see in the next 2 points the market and where the water industry is moving towards AI and intelligence in our systems, smart water supply by 2035, 100% smart meter penetration by 2050. So moving into gaining and understanding a lot more about our systems, gaining information, making informed decisions. Obviously, as well, private industries continue to look at their own strategies in terms of carbon reduction, carbon footprint reduction, and emissions as well. And that's an ever-evolving situation as well. I suppose with challenges brings opportunities. And we ourselves, thankfully, have availed a lot of those opportunities and allowed us to grow as a business. Uisce Éireann invests about 1 billion annually. I think this year they're set to invest about 1.1 billion in capital infrastructure. And this is set to increase to about 1.6 billion in revenue control period 4, which spans from 2025 to 2029 inclusive. So a huge amount of growth in terms of investment. The UK water sector invests about 10 billion annually, and obviously it's a much bigger geography. And they're about to embark on their new investment cycle in AMP8, similar revenue control period. In the private sector, I suppose industry and pharma continue to require capital investment in water and wastewater infrastructure. So I'm going to just spend the rest of the presentation just to highlight, I suppose, some of the opportunities that we have seen in the industry: early contractor involvement, sustainable solutions, modular design, DFMA, and offsite fabrication. I'm going to talk for a little bit about early contract involvement. I suppose how this has been a game changer for ourselves, the supply chain in general, and also for Uisce Éireann. I suppose just to give a little bit of a background as to how ECI came about. As I said before, Uisce Éireann would have been formed in around 2013, became active really in 2014. And the traditional procurement route for Uisce Éireann was to bid projects and release projects on a one-off lump sum basis out to the market, which meant that they had to issue information out to a consultant who would draft a concept design, sometimes obtain planning permission on that concept design, prepare a tender document, release it to contractors who would then bid the project. 5 to 6 contractors, depending, would bid a project. The tender would be returned, evaluated, awarded. Detailed design would follow on construction. Quite a lengthy process involving a lot of resources and a lot of different people for one outcome, one isolated project. I suppose Uisce Éireann, at the time Irish Water, would have engaged with a lot of stakeholders, including ourselves as contractors, and started to look at different delivery models of how they could deliver that large level of investment that I was detailing out earlier. And they embarked about delivering a program of work rather than isolated projects. Let's take a look at geography, issue out a program to specific contractors in a geographical region, and allow those contractors to work through that program. And I suppose the ECI, the Early Contractor Involvement Program, was one of those programs that was born, I suppose, out of that philosophy. And it was a pilot project initially. It commenced in 2018. And it was a 4-year program initially with options to extend by 2 years plus another 2 years. So we're in the first extension of the program at the moment. It's largely a 2-stage process. So we have what's called PCI, Project Commencement Instruction, which is essentially the early contract involvement stage of the project. So we're handed over what's called a project brief, a very brief document, as the name would suggest, about what the project entails. We will go to site, gather some information, some more data, raw water quality data, for example, flow and load surveys potentially as well. Then we start doing optioneering with the client, looking at what potential treatment solutions. We do various different workshops. We also form a risk register, and that is a shared risk register with our client and with their consultants. And as we develop through that early contractor involvement, we fine-tune the design, we eliminate risk, we do additional ground surveys, we do SI, we eliminate those risks and head towards what's called the target cost. Once we're agreed on that target cost, then we move into the second phase of the project, which is called PDI, or Project Delivery Instruction, which is essentially detailed design, so final detailing of some of the rebar schedules, for example, and then into the construction stage of the project. I suppose the ECI benefits are far-reaching. You know, we as contractors in Uisce Éireann, we have committed volumes of work. We have that pipeline and to look forward to. We have optimized design and innovation. We're designing at the right stage of the project, which allows us to innovate. There's very little design done when this is handed over to us, if any at all. So we're able to innovate, bring in new technologies, which we have done. We're able to reduce costs because we're working at the right things. We don't have multiple contractors and consultants working on design at the same time, some of which will essentially be thrown in the bin because there's only going to be one successful contractor. So we have resources working at the right things in a resource-constrained sector. That's very, very important. There's a shared risk. As I said, we developed the risk register together at the start. We have proactive risk reduction. It's open book, full transparency. And there's a collaborative incentive model. So we are working with our client, with Uisce Éireann, their technical assurance consultant and their planning consultant, and we're getting the best out of each one of those groups of people. We're set KPIs. We issue quarterly board reports as an ECI group. We have KPIs not issued to the contractor or to the consultant, they're KPIs for the team. We work together with our client as one team. It's a target cost agreement, as I say, it's open book, and that gives, this is publicly funded infrastructure. So there's an obligation on Uisce Éireann to have full transparency and demonstrate value for money, which the open book model does. There's full transparency there. And there is collaboration and trust, which underpins all of that. Everybody working on the same task for a common goal. I suppose, in contrast to that, the conventional versus the ECI delivery route, I suppose sometimes there can be a lack of clarity. You know, we're working in a traditional tender, we're working under huge time constraints to try and deliver a design that's robust and fit for purpose that we can stand over. There's conflicting objectives. You know, our clients might want to have the belts and braces in terms of a water treatment plant, and what we're trying to get the most economically advantageous tender in a short period of time, and ultimately there might be conflict within that. And again, differing agendas because of that generates internal stresses, and we have wasted effort, as I said before, in terms of maybe multiple contractors bidding a project with one successful, ultimately leading to failed outcomes. In contrast to that, with a collaborative type model, there's clarity of purpose, everybody's pulling in the same direction. We have joint objectives. As I said, we're all measured on the same KPIs as a team. Complementary skill sets, so we can pick very specific skill sets. So on the ECI we're involved in for the moment, we have ourselves as contractors, so we have the constructability experience. We also have our in-house design team. We have a technical assurance consultant who provides oversight and governance over our designs, make sure we're on the right track. We have our client, obviously, as well, another key stakeholder. And then we have a project management consultant, and the project management consultant then can take us and make sure we're keeping on track as regards the program. As the joint management, as I say, we're all one team delivering this. We have a joint program board, which I'm a part of as well, and we meet quarterly to review that quarterly report. And we've integrated processes, fully integrated team, and ultimately a mutual benefit. The graphic on the right-hand side is just to demonstrate the best time for design and innovation. As I said, in terms of project life cycle, it's at the start. So it's ensuring that we can influence the design and, I suppose, foster innovation at the right time. The longer it goes on into the project life cycle, the harder it's going to be to influence change and innovation and propose innovation. I suppose to summarize the shared advantages of the ECI, the collaborative design construction process focused on quality and efficiency, one team, one goal, heading in one direction. Speed of mobilization, because we have that pipeline of work, we're able to plan projects to roll one after another in a fixed geographical region and build teams, and that allows us to mobilize to these projects within 1 week of contract award. I suppose two project examples would be leak slip UV, where we undertook to install UV treatment process there. This was a design, construction and commissioning project, was completed within 8 months. I suppose a traditional model of appointing a consultant, doing a concept design, procuring a contractor, detailed design from the contractor and construction would take approximately 3 years. Similarly, Boherby wastewater treatment plant in Cork, which has just been completed at the moment, which actually required planning permission in this instance, still completed within 4 years. And again, the traditional model, we would have been looking at about 7 years. So we still very much involve consultants in terms of the design development. But I suppose rather than consultants doing a specimen design, those consultants are now working with us to develop the permanent design. It's most efficient use of resources then as a result of all of this. We're not tying up people in multiple different processes and steps, tendering multiple projects. And it's an open book model. So again, this builds trust and provides full transparency of cost to the client. There's an incentivized pay and share, gain share mechanism within this, just to make sure that we're all heading in the same direction and we're, I suppose, promoted to be efficient because we ultimately share a gain with the client in that respect. For me personally, I think this is a game changer for the industry. It was the first of its kind in the sector in Ireland here, and I'd say it's definitely set to be the future of contract delivery, definitely in the water sector, and I'd say there's opportunities within the wider civil engineering space as well. Sustainability, I'm probably going to 2 slides on this really. One about kind of what's happening, I suppose, at the moment in the water sector, and then another one then about what the future of sustainability looks like. I suppose Glanua as a company, our vision is to be a leader in the water and wastewater industry by providing sustainable and innovative solutions and technology, I suppose, that will ultimately positively impact our future and meet the circular economy needs as well. In terms of what's happening right now, renewable technologies that need no introduction. Examples, solar panels, that's Thurles water treatment plant in County Tipperary, where we install a solar system on top of the water treatment plant to supplement the energy supply on the plant. Anaerobic digestion probably primarily exists on the larger wastewater treatment plants at the moment. I think there's definitely scope to roll that out to the medium-sized treatment plants as well, potentially even with the smaller plants on a more containerized type, modular type basis. We also install a lot of hydroelectric turbines on plants. So where we would have, for example, mountain lakes or mountain streams or rivers supplying into a water treatment plant, we can harness that excess delivery head, put it through a hydroelectric turbine, and generate electricity to part supply the plant as well. We also have nature-based solutions, which are key as well. The photograph actually is of sludge drying reed beds in County Carlow that treat the wastewater sludge developed on the site, and meaning that it doesn't have to be transported off site, again, increasing the carbon footprint of the wastewater treatment plant. There's also a lot of work being done on integrated constructed wetlands. I know there was a pilot project down in Kerry a couple of years ago, and I think there's plans to roll out a few more ICWs as well in the near future. They're probably a little bit more restricted. They have a large footprint required for effective treatment, which probably restricts their use to smaller towns and villages, really, and places that have available land banks as well. Efficient equipment selection, it's been in operation for years now at this stage, needs no introduction, but that's just to demonstrate, I suppose, that the capital cost of a pump, for example, and the installation cost of the pump is the tip of the iceberg compared to actually the operational cost and the maintenance cost of the asset. And obviously with higher energy costs, there's higher energy consumption. So where it might be perceived that a pump is maybe €2,000 more expensive, if it has 0.5% more efficiency, then it's going to pay off in the long run to have that more efficient pump, and obviously decreases the carbon effect also of the pump. I suppose in terms of getting to those previously mentioned net zero targets, I suppose the industry, perhaps we maybe know what kind of steps 1, 2, 3, and 4 are in terms of the net zero movement. And that probably involves some of the technologies on the previous slide, renewable energy technologies, integrated constructed wetlands, etc. But we probably just don't even know yet what 5, 6, 7, and 8 are. And that's where innovation in sustainable technologies comes in. I think we're all going to have to work together. There's a definite ask out there in the industry for supply chain, for suppliers and contractors alike to come to the table with our clients and try and innovate and come with new solutions. I suppose two examples of maybe what this might look like, and it just highlights how we're moving towards a more of a circular economy. Sludge is no longer seen, municipal wastewater sludge particularly, is no longer seen as a waste product. It's actually seen as a sustainable alternative material. And municipal wastewater sludge can be used in a process called pyrolysis, which is effectively combustion of sludge or any organic matter for that reason, with little or no oxygen, which generates a byproduct called biochar. And biochar can be used for soil conditioning, for example, so it's a useful byproduct. I think we're also going to see a lot more of a move towards alternative materials. Certainly alternatives that have a low carbon footprint, and we may even have to force ourselves to look a little bit at things like where traditionally we would have looked at a water tank as reinforced concrete. Do we look at alternative materials such as steel, which might have a lower design life, but maybe it's recyclable at the end? All these different considerations will come into play. So just in terms of modular design then, I suppose the industry is definitely, like a lot of industries in the construction sector, is moving more and more towards offsite manufacturing and assembly. Probably a little bit more challenging in the water sector because of the scale and the size of the assets in terms of tanks and infrastructure in general. But we're always looking to see what we can modularize. The photograph actually on the slide there at the moment is of a modular water treatment plant. We're building 6 of these at the moment for Uisce Éireann, which essentially is a mobile water treatment plant that can be lifted on the skid frame, as you can see, transported on the back of a truck, dropped on site. We connect the pipework, the power, and into operation. I suppose the benefits of modular construction are far-reaching. We have reduced time spent on site, which obviously reduces the health and safety risk on site. We have faster delivery times in a controlled environment. We have reduced downtime and interaction with the existing system because it's all manufactured off-site, dropped into place, connected up, and away we go. With greater quality control, we're in a quality controlled manufacturing environment with procedures around health and safety. We can complete factory off-site testing in terms of fat testing before the equipment leaves the facility. It's fully fat tested. And I suppose we have more effective risk management and less material wastage as well. We're able to control, we're operating in that controlled environment. And ultimately, it leads to a decreased carbon footprint. I'm going to play this video in a moment, hopefully, if it works. And this is a project spotlight, I suppose, on the power of modular construction. This is Northmore and Amersham in the Affinity Water catchment, where Glanua, formerly Glanagua, as we were known then, constructed 2 water treatment plants as part of accommodating works for the HS2 high-speed railway line between London and Birmingham. And I suppose there were concerns at the time that tunnelling activity in underlying chalk would contaminate the groundwater sources, rendering them unfit to supply communities in the west of London. So this project, I suppose, was done to safeguard the water supplies in the 2 plants. And a modular approach was taken to this for, I suppose, 3 reasons. Fundamentally, it was for speed of construction, because there was tight timelines to get the tunnelling activities underway. You'll see from the videos earlier, we're operating in a very tight space. We're in a very urbanized area. And ultimately, the plan here is that when the tunnelling activities are finished, this whole plant could be demobilized, moved to another site potentially as well in the future. So without further ado, there is audio to this. It's not going to play through, but I can actually talk through some of the elements as well. So you got all modular pipes you can actually see on the graphic moment as well. Glass line steel tanks. So we use 4D planning to link the program with the delivery of various. We can plan out the works effectively for each of the process units arriving on site. So you can see the level, the tightness of the site where we're working to deliver the project. So let's grab some of the finished system. Okay. That's it. Look, I suppose if you want to know any more information about those topics or Glanua as a whole, you can follow us on LinkedIn. Plenty more content. And thank you very much for listening, and I invite any questions.
We'll throw it open to the floor first, if there's any questions.
Andrew, obviously very on top, and I enjoy what you do always. You see the enthusiasm that you speak with there. Loads of questions that will come out of that. Just the first one that struck me was the early contractor involvement. Maybe it being used in other sectors. So they didn't try it in roads a number of years ago. I'm seeming to move away from it again. Just wondering, do you see any downsides with it, or that it might not fit in with some sectors as well as it does with the water sector?
Yeah, so just for those online, the question was that do I see any downsides with ECI? And I suppose would it potentially not work as well in other sectors as it does in the water industry? I suppose in terms of the ECI model that we have, I think the success of it is driven by the individuals and the team that's on it. I think if you have that rapport with your client and with the various different consultants that are there as part of the team, and you're all working in that same direction, and there's that trust and collaboration piece is there, like that's very important. I think that can be the downfall of the ECI program. Thankfully, that hasn't been the case in the ECI, and we have a very good working relationship with the entire ECI team. I don't think it really has many downsides apart from that. You know, that's a risk probably more so than a downside, but it definitely has a lot more benefits than it would drawbacks. You know, other sectors I suppose that I could see it working in potentially. Look, I think it could be far-reaching. You know, in terms of, I don't know, would it be pragmatic to say that it would be rolled out full scale on you know, infrastructure projects such as roads and that, you know, that they're larger, more infrastructure based projects, but certainly maybe on something like repair and maintenance type programs in the roads industry potentially that are more minor works related. I think there is still space even in the water sector for those big, you know, capital infrastructure projects, multi-million euro projects that do require that sort of one-off. Let's concentrate, look at this project as a one-off isolated project and put a structure and a team around that. So.
Just in the municipal sector, you mentioned in presentation just with Uisce Éireann and their capital investment, also in the UK, they're on strategies in the next year or two. Where do you see their biggest challenges? Because how do you see the Glanua system achieving some of these?
Yeah, so just again, for those online, the question was, what do we see as the biggest challenges for Uisce Éireann in their RC4 investment plan and AMP8 as well in the UK sector? I think one of their biggest challenges is going to be shortage of a skilled workforce to deliver the investment plan. I think there's a large shortage, as I said before, in engineering expertise in this country, and also we're seeing the same issues in the UK as well. There's a shortage on trades as well to get to that, you know, level of infrastructure delivery. And I think you've got this competing element of net zero carbon. I think that, you know, those goals of net zero by 2030 in the UK, net zero even by 2040 in Ireland, rightly so, they're ambitious goals, and we have to strive to achieve them. But there's a lot of innovation to be done to get to that point. And, you know, in terms of carbon, you know, we're always going to strive to get towards carbon neutrality. But there will be a certain time where we'll limit the carbon as much as possible, and then we have to look at carbon offsetting. So carbon offsetting in terms of use of renewable technologies, or doing green initiatives in terms of offsetting that carbon footprint of the final asset base. But lots of different challenges there, but I'd say resources and that net zero target is going to be one of the key ones.
Just I guess follow up, maybe you mentioned the resources and the shortage for the next 4 years, 5 years, and recent years, Uisce Éireann.
Yeah.
See it in the banner here to the left, the graduate program. What does Glanua offer graduates? I graduated myself on slide 1T in civil engineering. They don't have the name of the year I graduated. No graduate program, I graduated college. What's the graduate program mean now for graduates coming out?
Yes, so the question there was, what do Glanua, I think is the question, offer graduates, and what do, I suppose, graduates have to look forward to in the industry? And I suppose to be honest with you, there probably was a lack of awareness that engineers could have a career in the water industry. It wasn't something that was well publicized, I think, down through the years. But I suppose what the water industry offers to prospective engineers and even engineers in the industry, or not in the industry at the moment, I should say, is a multidisciplinary exposure to engineering. You know, in the water sector, you're exposed to mechanical, electrical, civil engineering, controls, chemical, process, etc. We've just launched our graduate program. We've taken on 21 graduates. 2 weeks ago, they were onboarded into our new graduate program. It's a rotational program where they'll undergo a 2-year program and 6-month rotations. And because we're a design, build and operate contractor, we get to expose them to the early stage pre-contract as such, tendering, and ECI, detailed design, construction and operational maintenance. And I think that's important for any graduate, because when they come out of college, they can get a feel for what they like best in terms of be it design or construction on site, and then make their decision after 2 years as to what avenue they want to progress with.
Great. Just a couple of questions coming in online. The first one is, what are the current challenges the water industry is facing in the pharmaceutical industry specifically?
Yeah, so I think in the pharmaceutical industry, I suppose to deal with water, first of all, it's obtaining, I think, a safe and secure supply of drinking water. As I said, we have upper pressures, I think, on our freshwater supplies in some instances, upward headroom pressures. So it's getting that source of water in the first instance and making sure that that's future-proofed and secure for all scenarios. And then I think in terms of purity then on that water, because obviously a lot in the pharmaceutical industry, it requires a lot of pure water as well. So treatment of the water as well. And, you know, we have ongoing challenges with emerging pollutants, for example, as well. It's well publicized in the media, micropollutants such as microplastics, PFAS. These are all challenges that are coming down the line. Certainly the approach in terms of the likes of PFAS is to deal with it at source. It's largely found in extinguishers, fire extinguishers, for example, which is now banned from fire extinguishers. So a lot of work has been done at that at source to try and alleviate those risks. On the wastewater side then, I suppose it depends on what the pharmaceutical industry obviously produces, but I suppose the waste from some of these pharmaceutical and industrial clients is quite a high potent waste. So I was looking at new innovative technologies to treat these high potency wastes. So our Glanua industrial side of the business would specialize in treatment for industrial wastewater, so those high potency wastes. Yeah.
Very good. A second question, there's a number of questions come in. How are Glanua showing they're achieving energy efficient and zero carbon targets on projects and actually delivering in this operation?
Yeah. So in terms of measurement, you know, we're like a lot of companies, we're embarking on our own carbon journey. So we're striving towards accreditation next year. In terms of our project delivery as well, we're actively monitoring our energy efficiency. So as I said, we're doing TOTEX analysis of our equipment selection in terms of pumps, for example. We're analysing the energy efficiency of those. We're also looking at doing some sustainability pilots, and we've done some work in the UK as well on sustainability analysis on particular projects as well. We're in discussions at the moment with Uisce Éireann on rolling out a sustainability pilot as well. So look, it's very much, as an industry, I suppose it's in the early stages of carbon measurement and sustainability initiatives, but definitely on track and heading that direction.
How do you ensure the successful handover of projects to operations UE, particularly training of LA/UE operators and post-handover support, etc.?
Yeah, I think the key for us really is engagement at an early stage in the project. So essentially, as soon as we move through the detailed design phase, we develop what's called a commissioning plan. And that commissioning plan would set out the various stages of commissioning, but also in terms of the stages involved in training, handover. Either if it's a DBO contract, it would be handover to our own operations team, or if it's been handed back to Uisce Éireann and the local authority staff, we'd undergo a training program with those stakeholders, and we develop out a training plan and ultimately track that through. In terms of the other key deliverable, I suppose, with handover would be a robust commissioning process and documentation trail. So we had a very detailed and robust inspection test plans and inspection test records, which are completed, and they follow each specific asset on the project, and they all form ultimately part of the O&M manual that's handed over with the plant as well.
Are Glanua looking at process emissions like methane off projects and designs too?
Yeah, look at that is a space. It's not something we've done a whole pile of at the moment, but it is something we have a partner involved in at the moment in terms of measuring those emissions as well. And it's interesting, a large majority of the emissions that arise out of the water industry actually come from open aeration basins. We use oxygen to feed bacteria in wastewater aeration basins, and a large amount of emissions, process emissions, actually come from those open aeration basins. So if we're over aerating sludge, for example, we're actually generating more emissions. So there's a lot of work being done in that space of limiting emissions to an E2B basis. And controlling, I suppose, the oxygen transfer within the wastewater treatment plants to limit the amount of emissions.
Okay. Are Glanua acting as the ECI contractor or sourcing ECI contractors? And if it's the latter, are they readily available?
Yeah, so we're a main contractor. So we are the ECI contractor. We're PSCS, project supervisor, construction stage on the project. I suppose our delivery model is that we would subcontract out packages of work. So we engage with our supply chain in terms of supply materials, but also with our subcontractor supply chain for civil engineering, building, mechanical, electrical, and ICA contractors. So, yeah.
Okay. Thank you. That's all the questions that we have online. Is there any other questions?
Yeah.
Yep.
I just wonder,
Yep.
and you just regarding net zero and renewables, just wondering, would you think of using any other renewable resources apart from solar PV, such as maybe electric hydro turbines, or is there anything else maybe that you have coming up that you might use?
Yeah, so just for those online, I suppose the question was, would we consider the use of any other renewable technologies, such as hydroelectric turbines or other renewable technologies? So I suppose we're partnered with a company called Uisce Hydro, and Uisce Hydro have a technology called pump as turbine PAT, and we've installed a couple of those products. So it's essentially a pump that operates in reverse, and we've installed those on a number of projects where we might have an upland source, be it a stream or a river, has excessive head coming into the water treatment plant. We pop in this pump as turbine inline into the pipeline, and we can use that excess head to generate electricity, which can power the plant. So the hydroelectric space is probably definitely one which is already active, to be fair. Solar, as well as I'd mentioned, definitely active and ongoing. I didn't see much yet in the water industry in terms of wind energy, for example. I know on smaller scale, you'd have combined wind and solar systems to power water meters, for example, on networks. You might see them at roadside kiosks and that. But on a larger scale, I've definitely seen it in the industries where you would see different manufacturing, pharmaceutical, industrial companies that would have their own wind capability and their solar capability, but not on a municipal space yet.
Another question. Are there any plans of processing the methane emissions by partnering with a petrochemical plant to produce a natural gas?
I suppose certainly it's probably something that's worth exploring. I suppose it'll come down to economies of scale, and if there was enough generation of methane off a traditional process to warrant that. There's definitely space in terms of the wastewater sludge itself, and that's on the larger scale plants. As I was saying, we're already seeing AD and as a source of gas, biogas as such, and that's definitely one space which is already active. I think there's probably more scope, all right, to roll it out into medium-sized wastewater treatment plants straight away. In terms of harnessing any other methane discharges of the wastewater treatment plant, again, it will come down to volumes and economies of scale as such.
Okay. And one more question. Yeah.
Question. UK seems to have a much more ambitious net zero target for 2030 than Ireland. Can you shed any light on it?
Yeah, I suppose it's driven by the regulator. I suppose in terms of Uisce Éireann. Oh, sorry, a question from the room here as well for those online was that the UK sector seemed to have more ambitious net zero target to achieve net zero by 2030, whereas Ireland was 2040 target, so it seemed a bit more ambitious. And was there a reason for that? I suppose the UK sector is probably a more developed sector. You have utility companies that have been in operation there much longer than Uisce Éireann, to be fair, and there's probably Ofwat is the regulator in the UK, have set those stringent targets for the utility companies out there. As regards Ireland targets, look, I think there was greater investment needed in the first instance to resolve things like untreated discharges and get those sorted out, and ensuring that we secure sustainable and reliable sources of water treatment as well. And I think, that we have to secure those first, and bearing in mind that There is still intermediate requirements of 50% energy reduction by 2030, 51% CO2 emission reduction by 20. So there is still targets there, but I think there is more pressing issues, I would say, to get resolved as well. Yeah.
Following on from that, do water charges have any, do the countries have any impact on that 10-year difference there?
Yeah, so the question there was, do water charges have any impact in that in terms of the difference between Ireland and the UK? I wouldn't think so, to be fair. Ofwat, the regulator in the UK, sets the water charge rates in the UK. Ireland, I suppose, is different. We have a long history, obviously, as we're all aware, of water charges in this country, and the water infrastructure in this country is funded by public. It's publicly funded infrastructure. We don't have a water charge model at the moment. I don't think so. I think it's a regulator that's setting those targets and those ambitions. I don't think it's funding restricted as such. I think the funding is committed by government in both jurisdictions to make any investment happen.